If our differential equations is not separable or is not homogeneous, is there another way to find solution of the differential equation? What's up, guys, and welcome to differential equations. In this lesson, we're going to take a look at another technique or method in solving differential equations. We'll be learning about exact equations. But first, let's take a moment and reflect today's gospel thought. Let us remember that we are in the holy presence of God, in the name of the Father, the Son, the Holy Spirit. Amen. The scripture for today is from 1 John 4:20. It says, "If anyone says, 'I love God,' and hates his brother, he is a liar. For he who does not love his brother whom he has seen cannot love God whom he has not seen." Your siblings can really rub you the wrong way sometimes. They know which buttons to push to get you really mad, and they're not afraid to push them. Living with and getting along with siblings can really be challenging at times. This Bible verse offers some thoughts on getting along with a brother or a sister. It says that those who say they love God but hate their brother are liars. These are pretty strong words. However, they show us that loving those around us, like our brothers and sisters, is really important to God, which means it should be important to us too. So, the next time your brother or sister is driving you crazy, remember what this verse says and choose to love them instead of hating them. As Lasarlians, let us pray. I will continue, O my God, to do all my actions for the love of Thee. Saint John Baptist de La Salle, pray for us. Live Jesus in our hearts forever. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Alright. Previously, we have seen how homogeneous functions can be transformed to separable by introducing y is equal to vx and its derivative dy over dx equals v plus x dv over dt. Remember that? If a given function is not separable and homogeneous, another technique one can employ in solving DE is through exact equations. But what is an exact equation? Let's define it. The differential form mxy dx plus nxy dy is said to be exact in a rectangle R if there is a function fxy such that the partial derivative of that function fxy, as mentioned earlier, is equivalent to m, itong form na to, and if we take the partial derivative of the same function f here with respect to y is nx of y from this form. That is for all xy in R. Now, this is the total differential fxy if it satisfies this given function, such that the derivative of the function fxy is equivalent to yung components ng mxy dx plus nxy dy. If that is satisfied, then the equation mxy dx plus nxy dy equals to 0 or fxy is equal to z is called an exact equation. Okay? Let's take a look at an example para mas lalo nating ma-appreciate siya. No? To illustrate what an exact equation is, let's take a look at this example. So we have x squared y cubed dx plus x cubed y squared dy equals to 0. Is an exact equation because the left-hand side is an exact differential. What do we mean by that? We will notice that the total differential of the solution fxy, which is in this case the derivative of 1/3 x cubed y cubed, satisfies the given differential equation, which is in this case is this one, x squared y squared or y cubed dx plus x cubed y squared dy. Ito yung given natin. This is the solution that satisfies this differential equation. Now notice that it has a form mxy equals x squared y cubed, which is this part. And nxy is equal to x cubed y squared, which is this part. Right? If we take the partial derivative of m with respect to x, or with respect to y rather, and if we take the partial derivative of n with respect to x, we'll notice that it is equal. Now, this is very important because how do we know if a DE is exact or not? This brings us to a theorem called test for exactness. We can know if a DE is exact by doing TFE or test for exactness. Alam nyo ba, konting kaalaman, na itong theorem na ito ay napatunayan ni Leonard Euler noong 1734? Ngayon, alam mo na. Suppose that the partial derivatives mxy and nxy are continuous in a boundary called rectangle R. Then, our form mxy dx plus nxy dy is equal to 0 is an exact equation in that boundary R if and only if, okay, if and only if the compatibility condition, ito yon, partial derivative of m with respect to y equals partial derivative of n with respect to x is equal and holds for all xy in that bounded region R. Ibig sabihin, yung definition natin for test for exactness ay itong equation na ito. Para malaman natin kung ang isang differential equation ay exact differential, we need to employ this definition. And how do we do that? If we have a given function, say f, xy, we take the derivative of that by identifying first kung ano yung mxy dy or dx, yung part na to, differentiating this part with respect to y. So when we are differentiating with respect to y, we'll treat all other variables as constants. Okay? Ganun din naman dito, we take this part and differentiate it with respect to x. Yan. When we differentiate with respect to a particular variable, we will treat other variables as constants. Okay? So, I present to you two methods in solving exact equations. Okay? I will tackle first yung ating method 1. Una, we have what I call preliminary steps. Ito yung steps to identify all our ingredients, so to speak, no? To be able to proceed with the real steps. So, itong preliminary steps na ito ay yung steps A and B. I call steps A and steps B. Yung step A is, of course, first to identify kung ano yung m, xy, and nxy doon sa given differential equation. The next step, after nating ma-identify yun, is to test if the equation is really exact or not by employing our definition for test for exactness. That is, taking the function m and differentiating it with respect to y, taking the function n and differentiating it with respect to x. So these are all preliminary steps. These are important steps though that we must consider because if the function is proven not to be exact, then hindi na kailangan ituloy pa yung mga succeeding steps. Now, ito na talaga yung meat ng ating steps no, in solving exact equations. After proving that the equation really is exact, what we need to do is this. If m dx plus n dy is 0, equal to 0, is exact, then the partial derivative of that function with respect to x is equal to m. No? What we do with that is we integrate this equation with respect to x to get. Yan. So, may given tayong function. Okay? We take the m part, itong m dx na to, no? And we integrate it. Ito yung tinatawag kong mdx step, no? Miriam Defensor X. We integrate m dx and then we represent its arbitrary constant as g of y. The next step is, after integrating yung m dx natin, we proceed with determining what that arbitrary constant is, no? And how do we find g of y? Excuse me. We take the partial derivative of the result of this integral, no, with respect to y of both sides of the equation above and substitute n for partial derivative of f with respect to y. Okay? Then we can solve for g prime of y. Okay, now, the next step is to integrate g prime of y. Kasi di ba nag-differentiate ka sa last step? Nung nag-differentiate ka sa last step, meron kang function na derivative g prime of y. Now, kailangan natin i-integrate yan para makuha natin yung g of y. At yun yung ating magiging up to a numerical constant. At yun yung magiging g of y natin na isa-substitute back natin papunta sa f of x, y. Which is yung nakuha natin dito sa step C. Ito. No? So, ang gagawin natin sa g of y, i-differentiate natin siya. And then, i-integrate natin siya sa step E. And then, yung resulting answer ng g of y, isa-substitute back natin papunta dun sa f of x, y natin. Now, the solution m dx plus n dy is equal to 0 is given implicitly by f of x, y is equal to c. In other words, itong step F, you will form the general equation wherein yung f of x, y mo, now with your g of y determined, i-equate mo to c. So, that is the implicit solution of your differential equation. Now, alternatively, we can actually start with n naman by taking the partial derivative of f with respect to y equals to n. Dito naman, ang mangyayari, instead of integrating m dx, ang i-integrate natin ay si n, and then yung ating i-integrate siya with respect to y. So, n dy naman yung ating gagawin doon. So, to summarize, we have here, ito yung diniscuss kong method kanina. Partial derivative of f with respect to x is this mxy component. And then alternatively, pwede mo rin namang kunin yung partial derivative of f with respect to y and equate it to nxy. Okay? They will both give you the same answer. So how do we do that for this part? Una, to summarize the steps, no? We need to identify mxy and nxy. Next is we need to test for the exactness of those function m, no, with respect to y and n with respect to x. If they are equal, then they are exact. If they are not equal, then di natin dapat gamitin tong method na to because they are not exact. Step C rather. We have to integrate m dx, no? And then take into consideration yung ating arbitrary constant, g of y. So I call this step C, the m dx step. After integrating it, we take the partial derivative of f, which is etong equation na to, na nakuha natin dito, with respect to y. So i-differentiate natin yung result ng integration here with respect to y. But we also know that the partial derivative of the function x of y or xy with respect to y is also nxy. So ang gagawin lang natin, yung result dito, i-differentiate natin with respect to y while equating it to yung nxy component na nakuha na natin, na identify natin sa step A. After that, magkakaroon tayo ng expression for g prime of y. And for us to be able to get the constant, the arbitrary constant, we just simply need to integrate that g prime of y and we'll be able to get g of y and then plug it back here sa step C. And finally, after having all the ingredients ready, we can now form our general solution, and that is f of xy is equal to c. Itong part na to, now with the determined g of y, which is now this expression fxy, equate it to c, and that is your general solution. Alternatively, pagka naman kinuha mo yung n component, same preliminary steps, no? Identify m and n and then test for exactness. Dito tayo nagkaiba, no? Instead of integrating it with m dx, ito naman ay n and then dy. And then yung arbitrary constant natin dito, we call it h of x. Now, after getting x of y, fxy here, yung n component natin, kung dito nag-differentiate ka, partial differentiation with respect to y, dito naman partial differentiation with respect to x. And then, of course, we know that this component is equivalent to mxy. Makakuha ka na expression of h of x or h prime of x here. So we need to integrate that h prime of x for us to be able to determine yung arbitrary constant. Now, finally, pag nakuha mo na yung arbitrary constant, you can plug it back here sa step C, which is your fxy, and then form the general solution, which is just equating it to C. Yeah, so that is method 1. There is another method, and the difference in this method is found in steps C and F actually. C to F. No? Again, kasi itong A and B are preliminary steps. Kumbaga, identification and proving lang. So, dito nagkatalo sa steps C and F yung difference ng method 2 sa method 1. Kung mapapansin nyo, dito sa step C, mdx, kinuha natin yung integral ng mdx. And then dun sa step D, ang ginawa natin, we will be taking the integral of n xy dy. So instead of differentiating this with respect to y, we simply just integrate. No? So both integration. So finally, at step F, we form the general solution by equating the merged function of step C and D equivalent to C. Yeah, so fxy is equal to C. And that is our general solution for the exact equation. Okay, to better appreciate this, let's go straight to our sample problems. No? So let's take example number 1. Sorry. So we have here 2xy minus 9x squared plus 2y plus x squared plus 1, y prime is equal to 0. So let's try and solve this. So solution, no? Our first step is to identify mxy and nxy from the equation. We will notice na yung 2xy minus 9x squared plus 2y plus x squared plus 1 ay may nakamultiply na y prime. And we know that y prime is equivalent to dy over dx. Okay? Which is equivalent to 0. Now, wala pa siya dun sa ating form na m. We're looking for mxy dx plus nxy dy equals to 0 for us to be able to identify kung ano yung m and kung ano yung n. In other words, dapat merong dx to and dapat may dy siya. So, sa current form niya, wala pa siya sa ganung form. So, what do we do? Yung dy over dx, transpose muna natin sa kabila. Magkakaroon tayo ng 2xy minus 9x squared equals negative 2y plus x squared plus 1 dy over dx. Clearly here, we can see that dx can be cross-multiplied here, or as per my favorite algebra professor says, by multiplicative property of equality, we're going to get 2xy minus 9x squared multiplied by dx. Okay. Now, transferring this back to the left-hand side, we're going to get plus 2y plus x squared plus 1 dy equals 0. Ayan. Can now be easily identified that m here, mxy, is equivalent to 2xy minus 9x squared, and that n xy is equivalent to 2y plus x squared plus 1. Okay? Now, having identified m and n, we now proceed to our next step, which is the test for exactness. In here, we'll be able to know if the function is exact or not. And that is, per definition, it must satisfy this definition, no? Which is the partial derivative of m with respect to y equals to the partial derivative of n with respect to x. Okay. Sige, so let's take a look. We take the partial derivative of m with respect to y. That is, we differentiate the function m. Ito yon. Tama. This is our m. So in other words, we have 2xy minus 9x squared. Yan. So we can see here that the derivative with respect to y, when we are differentiating with respect to y, we treat all other variables as constant. So for example, itong ating x dito, we treat it as constant. So in other words, we're gonna get the derivative here with respect to y will give us simply just 2x. Now, since this x squared again, or x, is considered as a constant, the derivative of constant is simply 0. So, 0. Okay. In getting the partial derivative of n with respect to x, no, we simply differentiate with respect to x yung ating n component, which is this one. Right? So, this is 2y plus x squared plus 1. This will give us, again, differentiating with respect to x here and treating all other variables as y. We're gonna get 0, kasi nga y is considered as constant, plus 2x plus 0. Yan. We will notice that the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. They are both equal. They are both 2x. In other words, they are exact. The conclusion is that, yes, exact ang differential nito and can be solved by our methods for exact differential equations. So let's proceed to steps C and D. No? For our method 1, to demonstrate method 1, no, we take the integral f of x, y is equal to the integral of m xy dx plus g of y. Yan. So, taking the integral of m, identify na natin siya kanina. That's the good thing about identifying it. No? Ito yon, 2xy minus 9x squared. It lessens confusion, no? So 2xy minus 9x squared dx, and then of course plus g of y, which is yung ating representation for our arbitrary constant. So since we are differentiating with respect to x, we'll be treating x as our variable and y as our constant. So in other words, we can factor out 2 and y here and be left with x dx minus 9 and have x squared dx plus g of y. Okay. So, taking the integral, we have 2y x squared over 2 minus 9 x cubed over 3 plus g of y. This gives us y x squared minus 3x cubed plus g of y. This is our f of x, y. Okay. Now, after getting f of xy, we now proceed to our next step, which is finding the partial derivative with respect to y of our f of xy. Okay. But we know that this partial derivative with respect to y of our f of fxy is also equivalent to n xy. Yeah. So, yung ating fxy is this part, no? And then differentiating it with respect to y. So, copying this, we have x squared y minus 3x cubed plus g of y equals, equating it with nxy. Ano yung nxy natin? So, meron tayong yan. Now, taking the derivative of the function with respect to y, magkakaroon tayo ng x squared minus, since we are differentiating with respect to y, treating x as a constant, so 0 to, plus g prime of y. Kasi ang function niya is with respect to y. Equals 2y plus x squared plus 1. Can we easily notice that x squared here cancels out, no? And so we're left with g prime of y equal to 2y plus 1. Okay? We now proceed to our next step, which is getting the g of y, yung ating arbitrary constant. How do we get it? We simply integrate yung ating g of y. G prime of y. So doing it directly, meron tayong 2y, of course, dy, 2y plus 1 dy. This will result to integral of 2y dy plus integral of dy. Yeah. This is now equivalent to 2y squared over 2 plus y. Okay. So, obviously, yung integral ng g prime of y is g of y. Hence, g of y will give us y squared plus y. Ngayon, nakuha natin yung g of y, kompleto na ang ating sangkap, no? We can now proceed to our last step, and that is to form our general solution. And that is f of xy equals c. In our case, yung f of xy natin is this part. Yung nasa step C natin, ito yun, fxy. And we have identified g of y here. So copying, we have x squared y minus 3x squared plus g of y, which is y squared plus y. Combining them all, we're going to get x squared y minus 3x squared plus y squared plus y. Ito yung ating g of y equals to c. Yan. So there we have it. Our final answer for example number 1. This is the general solution. Okay? So for our example number 2, we have 2xy minus secant squared x dx plus x squared plus 2y dy is equal to 0. Let's now try and demonstrate naman. If we take the other root, no? Kung kanina we did m dx, why don't we take n dy this time dun sa ating step C? So let's try and do that. We have solution. Step 1 or step A, of course, is to identify mxy and nxy. Okay. Can clearly be seen here na yung form natin mxy dx plus nxy dy can clearly be noticed agad that m here is already 2xy minus secant squared x, no? By just visually checking it, no? Since mdx and ndy naman tayo, yun yung kanilang coefficients. Then, m kaagad is 2xy minus secant squared x. Whereas n, xy naman, is x squared plus 2y. Ayan. Now that we have m and n, let's now proceed to our next step, which is to test for exactness. Test for exactness, meaning they must pass the criteria of partial derivative of m with respect to y is equal to partial derivative of n with respect to x. So taking the partial derivative of m with respect to y is actually taking the derivative with respect to y of our m, which is 2x y minus secant squared x. So the derivative of this function is 2x minus 0, no? Kasi x again is considered as a constant. How about n? Partial derivative of n with respect to x will give us the derivative with respect to x of n, which is x squared plus 2y. This gives us, well, 2x, the derivative, plus 0. Yan. As can be noticed, these two are equal, no? What does that mean? This means that they are exact. Yon. The conclusion is that they are indeed exact. So we can proceed with our next step, which is B. Or rather C pala. And that is, instead of doing mdx, we're gonna go with ndy. So f of xy equals the integral of n of xy dy plus h of x. Yan. So let's do that. Let's integrate nxy. Yung nxy na identify na natin to be x squared plus 2y. So that is yan, dy, and of course plus h of x. So integrating with respect to y, we treat x as a constant. So labas natin si x squared dy plus constant y dy plus h of x. So integrating, we're going to have x squared y plus 2 y squared over 2 plus h of x. Hence, we'll have x squared y plus y squared plus h of x as our f of x y. Now that we have f of xy, we proceed with our next step, which is to differentiate with respect to x, yung ating function fxy na nakuha natin earlier, no? But we know that this is also equivalent to m of xy. And so equating the two, we're gonna get, taking the derivative with respect to x of the resulting function earlier, x squared y plus y squared plus h of x. Equating it with mxy, which is, kuha natin kanina, 2xy minus secant squared x. No? We are actually gonna get 2xy. So differentiating this part, 2xy plus y squared is considered as a constant, so this will be 0. Derivative of a constant is 0. Plus, derivative ng h of x rather is h prime of x. And then we have 2xy minus secant squared x. It can clearly be seen that 2xy cancels out. And so we have h prime of x equivalent to negative secant squared x. Now, what do we do with this? For us to be able to find yung ating h of x, we simply need to just integrate yung ating h prime of x. So that's our next step. Integrate h prime of x. So the integral of h prime of x is equivalent to the integral of negative secant squared x. Okay. So getting our arbitrary constant h prime of x here will give us h of x equivalent to, what is the integral of secant squared x? The integral of secant squared x is tangent x. Right? Naalala pa? Yan. So we have h of x already identified. What are we going to do with this h of x? Well, we have defined our f xy, which is the solution of our differential equation, to be x squared y plus y squared and then h of x. Yun yung kahalagahan niya kasi we will plug in h of x in this term. So let's go ahead and do that. And we're going to get a general solution formed by equating f of xy to c. So yun. So nakuha na natin kanina yung f of xy natin, which is x squared y plus y squared minus tangent x equals c. So there you have it, ladies and gentlemen, our answer for this problem. So we have seen how to use the alternative method, yung NDY. Let's now take a look at our third example. So, solution. Again, first step is to identify m and m. Now, from the given example, we can clearly indicate already that m is 1 plus e to the xy plus x e to the x y, because it's already in the mdx form, whereas the nxy is already in its ndy form. So x e to the x plus 2. All right. The next step is to do our test for exactness. That is, we must be able to satisfy the partial derivative of m with respect to y equal to the partial derivative of n with respect to x. So the partial derivative of m with respect to y is actually the derivative with respect to y of 1 plus e to the x y plus x e to the x y. And taking the derivative with respect to y, we actually treat all other variables as constant. So in this case, x will be our constant. So differentiating, we're going to get the derivative of a constant is 0. The derivative of e to the xy is e to the x. Say we're treating e to the x as a constant, right? Plus x e to the xy will give us x e to the x. Let's now take the partial derivative of n with respect to x. This is actually the derivative with respect to x of x e to the x plus 2. This will give us x e to the x will actually be by product rule. No, we have taking the first term, differentiating first the first term x, or the variable x. We're gonna get e to the x plus x e to the x because eu du. So this is product rule, and of course plus 0. Okay, plus 0 kasi this is a constant. All right, what can we notice? We can notice that yes, we have satisfied the condition partial derivative of m with respect to y equals partial derivative of n with respect to x. Therefore, our conclusion is that they are indeed exact. Right. We now move on to our third step, and this time around, we're gonna use our second method. Okay. And our second method is, still remember, m dx. Taking the integral of m with respect to x. So integrating, we have m. Recall na yung m natin is 1 plus e to the xy plus x e to the xy. Of course, with respect to dx. Now, in this step, we will now be disregarding our arbitrary constant, no, for the moment. Kasi later on, we will be merging this. So let's go ahead and integrate this. We're gonna get the integral. Let us distribute dx to our whole equation. So we're gonna get dx plus since x is the variable we will be differentiating to, so we'll treat y as a constant, factoring out y e to dx dx. Okay, and here as well we have plus y x e to the x dx. All right. So integrating dx will give us x plus y. The integral of ex is eu du. It's also e to the x, correct? Plus y. How about this term? How do we integrate this one? If we use u du, I think it won't be effective. Trig identity, no. we can use IBP, integration by parts. Okay, and how do we do integration by parts? IBP, recall, is the integral of UdV equals UV minus VdU. Yan. In our case, yung UdV natin is x e to the x. Okay. Now, we let U. How do we let U? What is our criteria in choosing for U? Nux, choosing U. We actually have a criteria for that. And the recommended criteria for choosing U is what we actually have already discussed in a previous example is Lie8. Okay. And Lie8 stands for logarithmic, inverse trigonometric, algebraic, trigonometric, and then exponential. Ito yung priority of choosing U. In other words, if we're going to take a look at the example, this is, we're gonna choose algebraic first before exponential. And from this given, we have two functions, no? Algebraic and exponential. Now, having this criteria, it is now obvious for us that our priority will be given to the algebraic, in other words, x, because our least priority is the exponential. So we'll put it in dv. That is e to the x dx. Oops, kalimutan si dx. Let me erase this for a while. X e to the x dx. Yeah. Okay. So differentiating, the derivative of x is, of course, dx. And the integral of v, because we will be integrating this, no, will give us v is equal to what? EU du, therefore e to dx. Yeah. So plugging in all our values, we're gonna get x e to dx dx is equivalent to uv minus v du. We have u times v is x e to dx minus the integral of v du, which is e to dx dx. And we know that e to dx dx is simply e to the x. So this will be x e to the x. And that will be our integration by parts. Okay. Now that we have that, we can plug it in here. And we're going to get x e to the x minus e to the x. Yan. Okay. So further expanding this will give us x plus y e to the x plus y or xy e to the x minus y e to the x. We'll notice that this will be cancelled out, no? And we're left with the integral of m dx to be equal to x plus xy e to the x. Yeah, x plus xy e to the x. Let us call this equation C, no? All right. Next, we move on to our next step, which is integrating n. Yun yung difference na with the other two steps from method 1. So we have partial derivative of m with respect to y and partial derivative of n with respect to x, right? Or vice versa. So we're gonna get, let's proceed to our next step, which is step D, and that is integrating n dx. Okay. I'm sorry, dy. N dy. The integral of our n, which is x e to dx plus 2 dy, yeah, is actually equivalent to this will give us, is actually equivalent to factoring out x e to dx, kasi we're integrating with respect to y, no? Plus 2 dy. Yan. This will give us y x e to dx plus 2y. Again, disregarding muna yung ating arbitrary constant, no? Kasi we will be merging this with our equation C. So let us call this equation D. Okay. So our next step is to merge. Merge steps C and D. Such that there is, or there should be, no repeating terms. Yon. And that will be our fxy. Okay. So let's take a look at our two equations, no? We have here C and D. What can we notice? This is our equation C, which is mx plus xy e to dx. And this is our equation D, which is n, our n, dy. Okay. We will notice that they have a similar term. What is that? Their similar term is actually this term, xy e to dx and xy e to dx. So what are we going to do with that? We're simply gonna copy it, merge the two. So this equation, x plus xy e to dx, xy e to dx plus 2y, without repeating term. In other words, our f of x, or rather fxy, will become fxy equals x plus xy e to dx plus 2y. Yeah, so we have merged the two. And for our final step, we simply form the general solution by equating our f of xy to C. Okay, equating it to C. Yeah. So f of xy is this already, right? Nasa baba. So we simply have to equate it to C. And this will give us x plus xy e to dx plus 2y equals C. And there we have it, ladies and gentlemen, our answer for number 3. X plus xy e to the x plus 2y equals C. Okay. Let's now proceed to our fourth example. Let's try and use that method once again. Solution. Okay. So again, the first step is to identify, which is M and N. Okay. M here can already be distinguished, no? Because from the form M dx, it's clearly evident that e to the 2y minus y cosine xy is our M, and our N is 2x e to the 2y minus x cosine xy plus 2y. Yan. Is our N. Next is to test for exactness. And that is to satisfy partial derivative of M with respect to y equals partial derivative of N with respect to x. So partial derivative of M with respect to y is actually the derivative with respect to y of e to the 2y minus y cosine xy. So differentiating with respect to y, we will treat all other constants as variable. In this case, we'll treat x as our constant. X as our constant. So we're gonna get e to the 2y, eu du will give us 2 e to the 2y, right? Minus, okay. So what we have here? We have here y cosine xy. We have our variable y, and we have another y which is inside cosine. So this can be solved by product rule. So taking the derivative of the first variable y, we're gonna get cosine xy. Okay, cosine xy plus yung derivative naman ng second, which is cosine xy. Derivative of cosine is negative sine u du, where our du is x, right? Yeah. So we're gonna get 2 e to the 2y minus cosine xy plus negative times negative xy sine xy. Now let's take a look at the partial derivative of n. With respect to x naman. And that is taking the derivative with respect to x of 2x e to the 2y minus x, natin to, minus x cosine xy plus 2y. Okay. taking the derivative of it will actually give us, with respect to x, no? So treating y as a constant, this will give us 2 e to the 2y. Minus x cosine xy. Again, by product rule, we have cosine xy minus or plus. Derivative ng cosine is again negative sine u xy, and du is sine u du is, I'm sorry, meron palang x dito. So the derivative of this x cosine xy is x, and then sine u du is negative. Sorry. Derivative of x cosine xy is x, no? And then negative sine xy, and then du, which is y. Yeah. Let's move this a little bit. But we know that the derivative of a constant, in this case, is 2y, because we treat y as a constant, is equal to 0. Yeah. Okay. So expanding further, this will give us 2 e to the 2y minus cosine xy plus xy sine xy. Interestingly, we can notice that they are actually the same. In other words, the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. This means, since it has been satisfied, this means that the equation is exact. We can now proceed to our main steps, no? Which is m dx, taking the integral of m dx. Okay. So we take the integral of our m, which is e to the 2y, minus y cosine xy. Of course, dx. So integrating, since y is considered as a constant, we're going to factor this out, e to the 2y dx minus integral, factoring out y again, the integral of cosine xy dx. This will actually give us e to the 2y x minus y cosine xy. The integral of cosine x is sine, right? But how about this angle? For this angle, if we let u be equal to xy, we're gonna get du equals y dx, correct? Kasi we're treating y as a constant. In other words, kung constant si y, we have to insert y here. In other words, dx will be equivalent to du over y. So, expressing that, we're gonna have y. The integral of cosine is sine u du. We have sine xy all over y. So clearly, we can cancel out y here. And we'll be having e to the 2y x minus sine xy. Let's call this equation C. Okay. In method 2, the next step is to integrate n with respect to y. And this will give us the integral of 2x e to the 2y. E to the 2y minus x cosine xy plus 2y. Of course, dy. So integrating, we pull out 2x because it is considered as a constant, minus x again, cosine xy plus 2y dy. Okay. So e to the 2y, integrating it, no? EU du, u being 2y and du being 2. So we need to insert 2. We're gonna have 2x e to the 2y over 2, right? Minus x, similar with what we did and in previously here in m. The integral of cosine is sine, but we let u to be xy and du will be in this case. So if we let u equal xy, du in this case will now become x dx or dy, because we're integrating now with respect to we let u to be xy and du will become x kasi we're differentiating with respect to y. Therefore, dy will be du over dx, making this sine x xy all over x. Yan. Plus, of course, 2 and then y squared over 2. Simplifying, we'll get this cancels out, see 2, right? X cancels out, 2 cancels out. We have now x e to the 2y minus sine xy plus y squared. Let's call this equation D. Now let's try and compare our equation C and equation D. We will notice that they have a similar term, and that is sine xy. Negative sine xy. So we'll simply copy this, merge the two, no? And we're gonna get, moving on to our next stage, which is E, merge C and D. Of course, with no repeating terms. This will give us x e to the 2y minus, copying those 2, sine xy plus y squared equals f xy. Yan. This is now our solution. Now, forming the general solution, and that is fxy equals c, will give us x e to the 2y minus sine xy plus y squared equals big C. Okay. And that, ladies and gentlemen, is our solution for problem number 4. Let's now proceed to our problem number 5. So for problem number 5, we have dy over dx is equal to xy squared minus cosine x sine x over y, quantity 1 minus x squared. Now we're given here a condition, and that is y at x is equal to 0 is equals to 2. Is equal to 2. Okay. So solution, first identifying our m and n, of course, will make our lives much easier. In this case, hindi pa siya naka-express to that. So we need to, well, cross-multiply, it seems. So we're gonna get, we'll have y, 1 minus x squared, dy equals xy squared minus cosine x sine x dx. Okay. So rearranging, we're gonna get y. Actually, we can put this here first. Negative x y squared minus cosine x sine x dx plus y 1 minus x squared dy equals 0. Okay. So we can now identify here which is m and which is n. In this case, our m is negative xy squared minus cosine x sine x. So we'll have negative xy squared plus cosine x sine x. And our n is y 1 minus x squared. So expanding this will give us y minus x squared y. Ayan. So we move to our next step, which is to test if the function is an exact equation or not. And that is test for exactness. So we have test for exactness. Yeah. That the partial derivative of m with respect to y should be equal to the partial derivative of n with respect to x. If this is satisfied, then the equation is exact. So let's do that. Let's take the partial derivative of m with respect to y. By taking the derivative with respect to y of our negative xy squared plus cosine x sine x. So we'll have, taking the derivative with respect to y and treating x as our constant. No? we're gonna have negative 2xy plus, since pareha silang x, constant, 0. Yan. Partial derivative of n with respect to x is actually the derivative with respect to x of y minus x squared y will give us, again, this is 0, and we have minus 2xy. Since both are equal, no, as can be noticed here, then the test for exactness is satisfied. Yeah. Our conclusion, therefore, is that yes, they are exact. So let's try and use again method 2 in solving this. That is taking the integral of m dx. Okay. So the integral of m, which is actually negative x y squared plus cosine x sine x with respect to dx. So expanding further, treating y as a constant, we'll have y squared negative integral of x dx plus integral of cosine x sine x dx. Expanding further will give us negative y squared x squared over 2 plus, okay, now how about this function? Cosine x sine x dx, no? How do we integrate this function? You can actually let u, no, to be equal to sine x. This will give us du is equal to cosine x dx, right? Now, by our rule, this will give us an integral of u du, and that is actually equal to u squared over 2. Yan. So this will become sine squared x all over 2. So this, simplifying, no, we're gonna get negative y squared or negative x squared y squared over 2 plus sine squared x over 2. Let's call this equation D or C, equation C. Proceeding to our next step, integrating n dy actually gives integral of y minus x squared y dy. Okay. So integral of y dy minus x squared y dy gives y squared over 2 minus x squared y squared over 2. Okay. Simplifying, we'll have y squared over 2 minus x squared y squared over 2. Let's call this equation D. Alright. Now we will notice, because our next step will be merging the two functions, we'll notice that we have some similar terms here, and that is this term and this term. Okay, so combining, we're gonna get, combining or merging C and D. Merging C and D, of course, with no repeating terms. From C and D, we're gonna have fxy equals negative x squared y squared over 2 plus sine x squared over 2 plus y squared over 2. Alright. Now finally, forming our general solution, gives fxy is equal to c. We have negative x squared y squared over 2 plus sine squared x over 2 plus y squared over 2 equals c. Okay. And that, ladies and gentlemen, is our final answer. Not yet. Because we have a condition. And we'll have to apply that condition. Okay. What is that condition? We have at y, at y is equal to 2, x is equal to 0. So, applying it in our equation, we'll have negative 0 squared 2 squared all over 2 plus sine 0 raised to 2 all over 2 plus 2 squared over 2 equals c. Okay, don't forget c, kasi we're actually solving for that c. So we'll have this obviously cancels out, becomes 0, and then sine 0 is 0. So we're left with 4 over 2, which is 2. 2 equals c. Yon. So substituting it back to our general solution, we'll have our particular solution as x squared y squared over 2 plus sine squared x all over 2 plus y squared over 2 equals 2. Yeah. And that finally is our answer. All right. Okay. So we have demonstrated here two methods, and it is incumbent upon you to choose which you prefer is the best method that you will use in solving exact equations. So, medyo maraming steps na kailangan i-employ, pero actually these are just formalizing those steps. You don't need to put in all the steps. But for a more organized and strategic way of solving this, I have placed it here so that you will get to see how these exact equations are solved, step by step. So I hope I made it clear. If you have questions, please do not hesitate to message me. This ends my presentation. So please do not forget to answer our problem set 5. Alright? So thank you for joining me. See you again next time. God bless.